Hello, today I will discuss the application of Varignon theorem for general force system. So first I will discuss the general force system, and then I will apply the Varignon theorem to find the resultant as well as position of the resultant from a given point on a body. Okay, so let's first understand what is general force system. So if I consider a body or an object and forces, okay, so this is the body or an object, and four forces are acting on this body: F1, F2, F3 and F4 as per this diagram, and all these forces are lying in a given plane. Okay, so the nature of the forces is coplanar. Now if I draw the line of action of all these forces, line of action of F2, line of action of F3, line of action of F4, then what we notice, the line of action of this force, this force, it means lines of action of all these forces do not coincide with x-axis or y-axis. Okay, it means these forces are acting at a random direction. These forces are not acting in horizontal or the vertical direction on this body. Okay, it means the forces are not parallel to each other. They are acting at different location or different points of body in different directions. Okay, so forces are acting in random direction. Not in horizontal or vertical direction. Okay, if this is the case, then we call it as a general force system. So now in general force system we have group of forces. Many forces are acting on the body in different directions, and if you want to convert many forces, the group of the forces, to a single force system, then we can use the Varignon theorem. So Varignon theorem can be used to find the resultant of all these forces acting on this body as well as position of resultant from a given point on the body. Okay, so the Varignon theorem find R resultant and position of resultant from a point on body. Okay, so we can use the Varignon theorem to simplify this general force system or the problems of general force systems. Now if we have a general force system, it means a object with many forces acting in different directions, then we can simplify this problem, or we can simplify such problems by using the Varignon theorem. So now I discuss the procedure to find resultant R and its position from a point on body. So first we'll resolve all the forces, means need to find horizontal, means x component, and vertical, means y component of forces. Okay, so this is the first task. We will resolve all the forces acting on a body along the x-axis and y-axis. So once we resolve all these forces, then the second step is to find resultant of so now second task is to find the resultant of x component, means Rx is x component, resultant of x component Rx equal to algebraic sum of all these components along the x-axis. Okay, so this is the algebraic sum of okay, so we will do algebraic sum of all the x component of the forces with a proper sign convention. So after finding Rx, we will find the next task is find the resultant of y components. Okay, means ry component ry is summation of y components. Okay, so this is again nothing but algebraic sum of y components with proper sign. Okay, so we first resolve the forces and then we'll find resultant of the x components. Means the x components now behave as a parallel force system. Okay, so we will find the resultant of the parallel forces along the x-axis, and then the y components is nothing but similar to a parallel force system along the y-axis. So we will find the resultant of y forces by taking the algebraic sum of all these forces or all these components with a proper sign convention. Now, after finding Rx and Ry, we will find the magnitude of R. Find R. Okay, so if you know the components of any force, then it's easy to find the resultant of that force. This is nothing but Rx square plus Ry square. Okay, so now we know. Okay, we know the resultant of. We know the magnitude of the resultant of a general force system. Now, in the next step, we will find sum of all moments of forces. Okay, it means this is nothing but the, if we represent with the MO, the moments of forces about a point O is nothing but the algebraic sum of moments of all these forces. Okay, so we will consider a point on a body, or let's say a specific point is given, or we need to find the moments about a given point on a body. Then we have to find, okay, we have to find the moments of individual forces, and then take we do the algebraic sum of all these moments. Okay, so this is nothing but again the algebraic sum of all the moments. Okay, so in this case we will also follow the sign convention. Means if moment of a force is in anticlockwise is positive, then is in anticlockwise, then we will take positive sign, we will consider positive, or in clockwise we will use the negative sign. So now you know the moments or the sum of the moments of all these forces. Now we will apply the Varignon theorem. Okay, the next task is apply Varignon theorem. So now my case is this one. Okay, so this is again the system of the body, and the x-axis, this is the y-axis, and this was point O somewhere here. Okay, now if I assume that okay, so I have considered the point O is here. Okay, I'm not taking this one. So now if I assume that my resultant is somewhere here, let's say this is my resultant R, and if I draw the line of action of the resultant and the point is here, and this distance between the reference point O and R is D, then moments of this resultant about point O is R into O, sorry, R into D. Okay, and we know that as per the Varignon theorem, the m naught, okay, is mo should be equal to mr. It means mo equal to r into d, or we can find mo divided by r. Okay, so we can use the Varignon theorem to find the distance of r from a given point on a body. Okay, so this is the, we can also, if I consider the earlier geometry, okay, let's say this is the O here, then let's say the resultant is somewhere here. Okay, my resultant is here. Then if I draw the line of action, and this is the reference point O, okay, so this is the distance D. Okay, so we can consider, can take point O to estimate the moments of all the forces, and then we use the same point to find the moment of resultant, and then we equate both the moments as per the Varignon theorem, and in this way we can estimate, or we can find the value of the distance of resultant from this reference point on body. Okay, so now we know the resultant as well as the position of resultant from a given point on a body. And now the next task is to find the angle. It means inclination of the resultant about a given axis. Okay, so the next inclination of r, okay, so now this is the point O, and this is the x-axis, this is the y-axis, and the components of my, this is the rx and this is the ry, and this is resultant, let's say. Okay, so my problem, I can represent my resultant. Let's say resultant is, okay, this is my resultant, and then this is the x components. Okay, if I resolve this resultant, then this is the rx, and this is ry component, and then angle theta here. Okay, so I can write, okay, now I can use, or I can find this angle theta. So tan theta equal to ry divided by rx, or theta equal to tan inverse ry divided by rx. Okay, so in this way we can find the inclination of r along about from the x-axis, okay, from the horizontal axis. Or we can find the inclinations or angle of the inclination from the vertical axis also, if we use the this rx divided by ry. Okay, so we will use always the positive value of these the components rx and ry. That's why we are using the mod. Okay, mod value of rx and ry. So this is a way to solve the force problem. So just summarize in 1 minute. So first, okay, we will look at the problems, and because since the general force system, so forces will definitely act in different directions. So first task is we have to resolve all these forces, means we have to find the x component, y component of all these forces, and then we will do the algebraic, we will find the resultant of x components, means we will do the algebraic sum of x component of forces by using the sign convention. Then we will find the resultant of the y forces or y components of forces. We will do again the algebraic sum of the y components of the forces, and after getting the value of the rx and ry, we will find the magnitude of the resultant. Okay, by this expression it means rx square plus ry square, root of rx square plus ry square. So up to here now we know the value of the resultant, but still we do not know the what is the position of resultant from a given point on a body. Okay, so we will consider a reference point, and then we'll find the moments of all these forces about this reference point, and then we will do the algebraic sum of all these moments of forces by using the sign conventions, means in anti-clockwise we will use the positive sign, in clockwise we will use the negative signs. After doing this, now we know the value of the moments of all these forces, or algebraic sum of the moments of all these forces. So now we know the algebraic sum of moments of all these forces, means m0. And then if we assume that resultant force, the magnitude of resultant force is r, and then this resultant, the distance between resultant and point o is d. Okay, then we can find the moments of this resultant about this point o. Then we will apply the Varignon theorem, means moments, algebraic sum of the moments of the all forces is equal to the moments of resultant about this point, or about a reference point. So after doing this calculation, we will find the distance of resultant from that given point on the body, and now we know the distance of the resultant from a point o, or from a reference point. Then we will use the resultants x component, y components to find the inclination, means what is the angle of the r with the x-axis. Okay, by using the magnitudes value, or by using the positive value of the rx and ry. Okay, so we can find the angle theta along the x-axis or along the y-axis by using